Assalamualaikum everyone. First, I would like to thank to the Management Committee of 5th International Eurasian Conference on Science, Engineering and Technology for giving me the opportunity to represent my research paper. The topic for today's presentation and of my research paper is durability properties of fiber reinforced geopolymer concrete having dolomite. So here is the little introduction of the presenter. My name is Mohammad Faizan Tahir from Department of Civil Engineering, UAT Taxila. So we have authors. This is basically the introduction of the authors. So first of all, let's start with the introduction to geopolymer concrete. It basically acts as a geopolymer. Concrete is an eco-friendly building material offering an alternative to traditional OPC, Orney Portland cement, and it basically produced from industrial byproducts like fly ash and ground granulated blast furnace slag, and it also significantly reduces CO2 emissions in the construction industry and possesses strong curing abilities and remarkable mechanical properties. Then we have polyethylene fibers in concrete. It is basically used to enhance the strength of geopolymer concretes. Like we see that it is more durable and long-lasting construction material, and adding these fibers to geopolymer concrete creates a composite material with superior qualities. Then we have role of fly ash. It acts as primary bender in geopolymer concrete, and it contributes to the strength and durability of geopolymer concrete and helps in reducing the environmental impact of concrete production. Then we have ground granulated blast furnace slag, GGBFS. It acts as a secondary binder in geopolymer concrete. It also enhances the concrete durability properties and contributes to the significant decrease in initial and secondary absorption rates of the concrete. Then we have dolomite in geopolymer concrete. It basically used to enhance the mix of the geopolymer concrete and used as a partial replacement for fly ash in geopolymer concrete, and improves the overall durability and strength of the concrete mix. Next we have basically the chemical features of fly ash, GGBFS and dolomite. You can see the various chemical compounds like calcium oxide, silicon dioxide, magnesium oxide, alumina, iron oxide, sulfur trioxide, and loss of ignition with various chemical contents in these chemicals like dolomite, fly ash, and GGBFS. Moving on to the next, we have the sieve analysis of sand and coarse aggregate. As we know that sand is a finer material and coarse aggregates are coarser. So this figure basically displays the gradient of both coarse and finer particles with different, we can say, the chemical combination composition we have used before are having a great impact on it. Then we have the preparation and testing of samples in mixed design. This is basically this shows the mixed design. We basically uses 6 different mixes. You can see the mix labels are mentioned using various ratios of fly ash, dolomite, and GGBFS. All the GP blends kept the same alkali to binder ratio of 0.45. Then we have the durability assessment. We basically perform 2 tests for the durability assessment. The first one is initial surface absorption, and the second one is capillary section absorption. These tests basically measure the concrete ability to resist water penetration, and the results we have seen after that. We will see that GGBFS significantly reduces the absorption rates. This indicates that a high durability of geopolymer concrete mix. So these are the results of initial surface absorption. These are basically the results of initial surface absorption. You can see the various graphs and the mix levels are mentioned here. The A figure is for 20 days of curing, and the figure B is for 90 days of curing. And you can see that after some time you can see the decrease in initial surface absorption, and this basically shows the Again, the figure A shows 20 days of curing, and you can see that decreased percentage in initial surface absorption values with reference to the control mix, and the figure B shows 90 days of curing. Then we have capillary suction absorption. Again, you can see the first figure. The figure A shows the 28 days of curing, and the figure B shows the 90 days of curing. These are basically, you can say, this is the initial rate of absorption. We have the different mix labels here, and these and above that there is a secondary rate of absorption. Then for mechanical properties, we did basically the strength analysis, and to assess the mechanical properties of geopolymer concrete, we performed the compressive and split split tensile strength test. The addition of GGBFS and Dolomite definitely impacts the strength of geopolymer concrete, and these tests basically shows the significant improvements in the strength with the use of these materials, and polyethylene fibers further enhances the strength and durability of concrete mix. Then we have an oven analysis, that is basically a statistical validation for our research. ANOVA analysis is used to confirm the variations in concrete strength, and this statistical method validates the result of strength test. It shows the significant differences due to partial replacement of fly ash, like we see before that, by adding GGBFS and the Dolomite, the strength of geopolymer concrete has enhanced. And this basically analysis confirms the effectiveness of GGBFS and Dolomite enhancing concrete properties. Then this is basically the ANOVA analysis result. You can see the groups, the mix labels we have. This is basically the counts, and this is basically the statistical calculation. You can see this is basically the compressive strength of GP mixes at 28 days. Then we have split tensile strength result. You can see the groups and the statistical validation and the calculation of ANOVA analysis. Then we have the economic feasibility. So this is also a cost-effective geopolymer concrete is evaluated for its economic feasibility as well. Using industrial byproducts reduces the overall cost of concrete production while maintaining the high durability and strength. So this basically makes a viable alternative to traditional Portland cement. Then we have conclusion and future direction. So it is basically a sustainable choice to use industrial byproducts in geopolymer concrete instead of traditional materials. So geopolymer concrete with polyethylene fibers is durable, strong, and eco-friendly construction material. Then the use of GGBFS and Dolomite enhances its durability and mechanical properties. So, and again, the economic feasibility makes it's a competitive alternative to traditional cement. Further research, because our research is not again at that much level, so further research can explore additional benefits and applications of this innovative material. Thank you so much thank you so much for giving me the opportunity to represent my research paper in 5th International Eurasian Conference on Sustainability in Civil Engineering. Thank you so much.